Hi, I'm Print for Fun, and in this video I will give you a tutorial on how to use the MetaInform 3. It's like a workflow explanation from me, mixed with some additional information about the hardware of the scanner and my own customization to the workflow, my additional accessories for the scanner to simply have an easier time scanning and get better scan results. Right, so as you can see, I already took the scanner out of the case. I did an unboxing previously, so you won't see the case again for me or in this video. But let's first have a look of the power supply of the scanner and how I added an additional power supply. This is the original power supply. It's quite a beefy unit, and it outputs 12 volts at maximum 5 amps. The scanner is also rated for 12 volts, 5 amps, but I quite like to use my scanners with these adapter cables. Basically, you can see on the one end we have a USB-C input. It's a power delivery input. This means if you have a suitable USB power supply, like this one, the cable requests 12 volts from it and outputs it over a barrel jack. So this is the same plug that the scanner uses. Keep in mind, or a bit of a disclaimer here, a warning, the 12 volt PD spec is normally only rated for 3 amps, so 36 watts. It's under the 5 amps the scanner is rated for. From my testing, so I've used the scanner with like a power analyzer at wall plug. The scanner never consumed over 30 watts for me. So I guess it will be fine, but if you're having like power or stability issues, you may prefer using the original power cable, since I guess this one is designed for the scanner. So now let's put this one away and have a closer look on the scanner. You can see here at the back we have a Wi-Fi antenna. This is the Wi-Fi antenna that was included with the scanner, but you have a standard SMA port for like any Wi-Fi antenna, or your PC mainboard also uses. I even tried one of my stubby antennas, so like a third of the length maybe. The stubby antenna I tried out simply didn't work with the scanner. If you have a proper other antenna, it may work, but at this time I see no reason why not to use the official antenna. Maybe a bit more about the hardware of the scanner. So on the front we have like the projector of the pattern in the middle and the two autofocusing 30 megapixel cameras. Internally, the scanner uses CM4, so a Raspberry Pi Compute Module 4. It's like a credit card sized mini computer, often used in this kind of embedded devices. I had a talk with a supporter. It was actually the CEO or co-founder of MetaInform, about potential upgrade path for the compute module, since, as you may know, or some of you may know, there is the compute module 5 now, so the follower of the compute module 4. But sadly, Raspberry Pi changed the pin out of the compute module, so this is quite inconvenient. So basically, you have to imagine it like this: the compute module is like a credit-sized PCB, and it plugs into connectors often used in mobile phones. And Raspberry Pi changed the pin out of the new compute module 5. Therefore, it isn't compatible anymore with the compute module 4. This is very sad to hear, since then there is no drop-in replacement or upgrade possible. But I guess it is as it is, and the scanner itself is also quite fast. So if you use the scanner and the software in the right fashion, the post-processing is very fast and doesn't take a lot of time. So I guess it's not a big deal, but I have an IPT background, and I was very excited when I initially found out it used a CM4, but then I Googled a bit more and read on forums, and it's not compatible. So first, to start the scanner, or let's talk about the scanning, how the scanner works. As I said, there's a compute module 4 inside, and this acts as acts as a server, or it's like an edge device where the scanner itself hosts a web server in your local network. This means you simply can connect the scanner to your network and then go to the website or the front-end website of the scanner over your browser and use it from any device that has a browser, or basically any device. It's best to use with devices that have like a screen size of a notebook or tablet. With a phone, it gets quite finicky to use, so I wouldn't recommend this. But yeah, it's quite a different usage experience, and also quite convenient. So especially for post-processing, I found myself using this, placing the scanner on my table after scanning like this and just plugging it in. So then I don't need a tripod for post-processing, and I just can do the post-processing on my tablet, laying on the couch or in the bed and having a nice tea. So I don't need to be placed on my computer. That's nice. So to start up the scanner or connect the scanner, first we will need power. So for this, I will be using the official power supply now. And the second thing you will be needing is a network connection. There are basically 3 options to connect the network, but let's first plug in the power. So basically it's the DC plug, and then you have this latching connector. So it's not a momentary switch, it's a latching connector. And then you attach the tripod to the scanner. This is the included tripod. This is also one of the options where you could, or I also like a bit adjusted my setup with the scanner, because this is like this kind of flexible tripod, but since I'm mostly using it in the scanner in my workbench or in my workshop, I often prefer having it on like a flexible camera arm. And since you have a standard camera 1/4" thread on the bottom of the scanner, you can attach it to any camera arm or any tripod you already have. So I have like a small rig camera arm attached to the backdrop of my workbench. And with this, using it or placing the scanner where I want it to be is simply a lot easier. Okay, we have the power connected. Now let's connect it to a network. You have 3 options to connect the scanner to a network. First one, or the first 2 ones, are wireless or Wi-Fi. The first one is the default one that works all of the time. In the first mode, the scanner creates its own Wi-Fi hotspot. And you simply join the hotspot. So the hotspot isn't password protected. You just join it on your notebook or your tablet. And from there on, you can either directly use the scanner or enable the second mode. And the second mode is where the scanner joins your existing network, so your existing Wi-Fi network you have at home or in your shop. And therefore you are connected to the internet. The scanner can pull firmware updates, and you can simply connect to the scanner without being close to the scanner. So that's quite nice. The third option will be a bit more interesting, maybe for people using it in a professional environment. Since the scanner has a Ethernet port, this means you can just connect the scanner with a standard Ethernet cable to your home network or to your switch. And so now I connect the scanner and I can boot it up now by pressing the latching button. And what's quite fascinating now with the 3 is its ease of use. So here I will be like using the big calibration board so you can see the projection. And basically it's like a beamer. So it's like any DLP beamer out there, miniaturized into a scanner. And now you can see it's searching for updates in the first step, since it is connected to my home network and therefore has connection to the update server. But you can, of course, always use the scanner completely offline. So there is no need to connect to the scanner, to connect the scanner to the internet. And now I directly see here on the projection of the scanner itself, okay, over Ethernet, you connect it to the either the URL or the IP address of the scanner, and it actually outputs them directly over the projection. So there's no need to go into the UI of your router at home or ask your IT admins what IP the scanner got. So this is, yeah, very convenient. So I already know the IP, so I can now take my notebook and connect to it. So it's the 192. No, this is the false one. It's the 143. Keep in mind, if you're using the scanner in Wi-Fi mode sometimes and in Ethernet mode, they have different IP addresses in the different modes because they are different network cards inside the scanner. The host name will be the same, so it's the metainform.local. It's the same in both modes, but the IP address is different. As said, it is best to connect to the scanner using a notebook or a tablet. You can also use it on your phone in desktop mode. I wouldn't recommend using it this way. I guess like at least screen size of an iPad mini is very beneficial. So as we are now connected, we can start a project for scanning. So let's click on New, and we will name it Camera Screw. Create project. And here you can see you have like the blank project now without any scans. And here we can add our first scan. And we are directly seeing the preview of the cameras. The model I want to scan is this small camera screw. This is a 1/4 inch threaded screw that's used for attaching cameras, action cam, anything with the fitting thread to your tripods. And I want to include this in one of my 3D printed designs. For this kind of round object, it is best, or for any scan with the metainform 3 actually, it is best to use the turntable because this is the default mode of the scanner. It's just the included turntable. It has like a pogo pin, a magnetic pogo pin cable. This is quite nice. So if you trip over the cable or accidentally pull the cable, you're not in the the danger of actually damaging the scanner or the port. But this also means the cable is only magnetically attached and can be wiggled use if you play around with the cable while scanning. Don't ask me how I found it out. And the connection port, the mating port, is directly on the backside of the scanner. So easiest would be to place the scanned object directly here on the scanner. This does work, but I would say there is a better way. At least from my experience, there is a better way. Because with the metainform 3, if you now look at the UI of the scanner, I can now like pull my focus on a part, set the exposure right, a bit brighter, and as you can see now, it's actually overexposing the reflective part of the metal. So we will need to use scan spray, otherwise the scan results simply won't be as good as they could be. I will be using like a medium scan density, or let's use the high scan density since it's quite a small part. And for high scan density, I actually found out from testing that a noise reduction value of 20 works the best or gives you the best results. For medium, I normally use a noise reduction of 10. So with the metainform 3, this is like one of the points you see, or one of the features you find all the time in UI. You have a lot of freedom. So if you just have a quick look at their scan settings, you can see there are a lot of sliders you could use. Honestly, I haven't played around with them quite a lot because I just don't want to mess it up. Of course, you can reset the scanner, but from my experience or from my guess, the default settings are already optimized. So I really don't see any need to do this. One additional information maybe about the update frequency for the Metainform 3. So there are like regularly coming firmware updates out. One of the features that will be implemented in a next update is like automatic. Normally the scanner always does automatic hole closure. And if we now look at one of the scans, so we will look at the plier scan, or it's actually tweezers. I chose the wrong word. And let's maybe quickly create a new mesh from it. It's like this. Now let's create a low quality mesh quickly. This won't take very long. The scanner always tries to close holes. And on mechanical parts where you only scan a bit of the, or only from one side, you will have these kind of artificial, I would say balloons sometimes, or planes that get created by the software in hole filling. With one of the next updates, there will be the option to actually disable this kind of automatic hole filling. So that's quite good to hear, because sometimes it's a bit of frustrating. But let's go back to our scan. And as you can see, okay, I will be needing scan spray. I could now directly spray the part here on the turntable. But then I have the problem, because if I now go to the next, we must calibrate the turntable, because the Metainform 3 it doesn't use features or markers for tracking. It actually uses the rotation of the turntable. So this is like no normal turntable where it's like simply maybe a cheap DC motor in it, and it rotates, and the scanner doesn't know where the turntable is. In this one, there are like optical encoders. So the scanner has an exact tracking of the turntable movement, and therefore this information can be used for alignment of the single scans, because it does basically one frame, then it rotates a bit, it does the next frame, and how much frames it takes can be set in the turntable tab here. So as you can see, I have this slider, and it actually directly gives me an animation of how it will look, or how much scans it will perform. For normal scans or medium density scans, 8 is fine. For high density, 10 could be beneficial, but keep in mind the processing time increases if you also start increasing all parameters. And if you now go to the calibration of the turntable in the next step, you see we now need to place the calibration board. So for the small part, I will be using the small calibration board on a turntable. And this also means we have to move our scan objects in between. So if you spray it now here, or spray it offside in our hand with scan spray, we touch it in between, and therefore there is the risk of like damaging or removing the scan spray code when placing the turntable. So I actually created a bit of a different accessory for the scanner, or it's a marker geometry. I chopped the part off, so it's like a black 3D printed part. It has like a textured surface on which blue tack, so like this stuff, it's a bit like play without leaving residues. Can be pressed on, and then I just can press on my object, my object I want to scan, and now I can coat it with scan spray, as you can see here. Keep in mind, scan spray is quite nasty stuff, so have a window cracked, as I have in my workshop, or maybe even via PPE. Maybe depending on what your company mandates or what scan spray you are using. I use AirZap Blue, so this one, it's quite like one of the most well-known brands. There's also RarePoint scan spray, and there is a new brand on the market. I guess it's called Reflection. I've seen them at Formnext. They're actually a German brand. That's quite nice. So now you can see with the scan spray we are quite overexposed. So let's drop down the exposure quite a bit, so we don't have any red spots. And now we can also talk about the placement of the part. Ideally, both cameras see the same image or roughly the same parts of the model you want to scan. Of course, for the scanning to work, both cameras need to see the model. So what wouldn't work is if I place the scanning table like this and only one camera sees it, or on one camera it's centered. So try to imagine that you have like a mirror line in between the cameras, and both pictures should look roughly the same. Also for smaller parts you can move closer. So maybe let's turn this a bit. Now we can move even closer. Of course, moving closer will result in a bit more detail scanned, but it may at some point, if you are moving too close, you're at like the narrow distance of the autofocus. This may create problems, and the calibration actually may produce a few problems, because then the scanner isn't seeing the turntable anymore. I've mainly been using the Meta-Inform Free for very small parts like this one. So I cannot talk much about the performance of scanning very tall parts. And also I'm using ScanSpray most of the time, because I'm mainly interested in the geometry. So if I'm scanning jewelry, electronic parts, or like PCB components, I don't mind the colors, I just want the geometry to be captured. And using ScanSpray simply provides better results, generally speaking. So I haven't been testing a lot of its texture capabilities, because the ScanSpray, as you may know, it is self-vanishing. This means now it looks like I added white spray paint, but after a few hours it will be completely gone. And the ScanSpray itself isn't very expensive, so the whole can is roughly 20 or 25 euros. It lasts for maybe 100 or 200 scans of smaller parts, and it drastically increased the scan results. So why shouldn't I use it and make my life artificially harder? Because I guess it is already quite hard, generally speaking. So now let's place the part, and now we can pull the autofocus. So pulling autofocus basically is grabbing the orange rectangle and just placing it on the part. If you have it placed, we can now calibrate the turntable in the next step, like this. And as you can see, it is seeing the turntable, so it's like highlighted the raster in blue, or the checkerboard in blue. So you now can press calibrate. The calibration itself doesn't take very long. So maybe what you're seeing here are 10 seconds, maybe 12 seconds, or maybe 20, I don't know. It's not too long. This is the small calibration board. There is also a larger calibration board for large scans, as you're seeing here. I haven't used it a lot because I mainly scan the smaller stuff, so I don't know. But now let's place the screw again on the turntable and perform the scan. When placing the screw on the turntable, or the object again, keep in mind you must hit the same position as before, and generally speaking, for all parts that you want to scan, try to center it as much as possible, because then the object is all the time in focus and in the scanning area. So if I would place it here at the side now, or a bit off center, this means that the part is rotating like this, and then sometimes it's in the picture of both cameras, sometimes not, sometimes the focus is off, so just placing the center, and we can hit the Start Scan button. While it is scanning, it now will perform 8 scans of 8 positions. Let's talk a bit about the calibration boards. They are quite different from standard 3D printer calibration boards, since they use this kind of printed on QR codes. I guess maybe they are Arico codes, as seen in VR goggles sometimes. I'm not completely sure. The calibration boards itself, they are made of some kind of very high density foam with plastic coating on both sides. And as you can see in some places, I actually managed to scratch them a bit while inserting the calibration board into the holder. So it gets put in like this. So be careful of the calibration boards. You don't want to scratch them, or actually you don't want to scratch the checkerboard in the center. So I guess at the sides where it is inserted into the holder, it's no big issue, but at the center you have to keep mind of it. Also, like on all 3D scanners, don't touch the plate. Only touch the corners or the edges of the board, since you don't want to get any smudge on it or discoloration. I don't want to scratch off the markers or the pattern, because then the calibration will be impossible or not as accurate enough anymore. I've seen the board can also be reordered, so if you would damage them at some point, I guess it isn't so drastic, but maybe just don't do it. All right. I must say, with the MetaInform 3, scanning, or especially the tracking part and thinking about how to place objects, is the easiest of all scanners I've actually scanned with. So since it uses the turntable for the tracking, the orientation is right. So it by default orientates the part in the coordinate system. So the turntable is like the base plane of x and y. It is the rotation axis, the center. And you don't need markers. You don't need to think about features. Normally, I just apply a code of scan spray and then start scanning. So that's quite nice. And now we can see we scanned the first side of the screw, and it's looking fine, I would say. Here on the side you can collapse the overview, and you can even see now the single scans of the turntable rotation being overlaid. So currently each one has its own color. You can also tap here on the question mark next to the group and set a global color. This is very beneficial if you, for example, want to perform merging, or just want to look at the whole scan result to determine if you need additional scans or if it didn't come out as wanted. By double clicking on the group, you can rename it. So this is the top side. And you can even now, if I select it, you can copy the group. So you can post-process the groups differently. So this may be quite nice if you want to maybe try out some things. But now let's delete the copy, we don't need it. And the only real post-processing we will be doing is cutting off the bottom, or like my base plate. This can be done with the cutting tool. Basically for all different options here, there are shortcuts. So for the camera view we're using now, there's the C button. So with C you select the camera, and for the selection, for the lasso selection, it's S. So we can now use selection, and here on the side, here on the bottom, you have the different options you can do for lasso. So currently here we are in the add selection function. We can like bit by bit create our selection. There's also the option to completely replace the selection all the time. So it works a bit like this. And if I create a new selection, it only selects this one. And you can also subtract the selection. So initially, I didn't pay a lot of attention on UI. So I was a bit frustrated. But if you have a look at it or read the manual, it's actually quite easy to use. Of course, we can invert the selection, but we won't be needing it. So let's delete the first part. But I will also have to delete the other parts of this base, something like this. Now with C we go back to camera movement, and with S again for the selection, like this, more like this. So, and we can delete it. All right, this looks quite good. And now I will perform the scan of the second side, and then you will be seeing me post-processing the tools together, so the merging or the alignment, and then the post-processing. So the second side just finished scanning, and as you can see, since the the hinge part is moving, I will have to cut it out because it moved in the second scan. It is a bit unfortunate. Maybe I should have used some super glue before scanning to fix this hinge, but I would say after scanning you are always wiser. But yeah, it will be fine for this scan because the rough dimensions are sufficient for me. So now let's cut off the hinge. So now for the alignment. We will actually, there are two options for to align. There's the auto alignment and the point pick alignment. Since there is very few actual overlap and it may be a bit, I didn't capture much, basically only captured the top side of the screw, so we will be using point picking of between the, so basically first you use a base, you select a base scan, and secondly you select the scan that you actually want to align. And what I quite enjoy with the Free is the point picking tool. So this is done quite nice because what you can do now, or what it does, if you drop or use these I would say numbers you drag and drop onto the scan where there's like common results, you get a zoomed in view. So this is quite nice and different from the scanners I've seen until now. Okay, we got 2 common points. Now let's search for the third one. Guess. Now it's, as you can see, without a lot of overlap, it's quite hard, but I know that there must be the icon. And it still wants a third point. Now let's align it and look at the aligned result. This actually looks quite good. Alright, this looks good. So now we can merge the scans. We will merge only the visible ones, but actually in our case all the scans are visible, so we can also select all. Merging is quite fast, and now we will do the, well, now we'll first delete some of these like flying points I missed earlier to prevent that there will be any mishaps when meshing. So I will mesh at a high quality. So let's look how long it will take for these smaller scans of like these small screws. It won't take long. I guess if you are scanning very small, large parts, I've seen with the in the advertisement they scanned a whole Vespa, like motor scooter. I won't imagine how long the meshing of the whole scooter took place. It took time, but for such a small scan, it won't be that long. So my results, So we are finished and it looks quite nice. We have a bit of surface roughness, but this is like one of the disadvantages of using the high resolution scanning. They also state this is one of the downsides, but I would say we are seeing like the small threading. We are seeing like the misthreading. So I guess these are also very cheap AliExpress ones. Now we can directly export it. What you can also do, it's like the software guides you to use step 2, simplify and convert. This basically is used to simplify the STL file, so to reduce the triangle count or the polygon count. You can also actually convert it to quads. This is like the step that would take the longest time on the scanner. You don't need to do it. You can also directly at this point either like first let's add the scan to the project. So like this. This actually adds the STL file to the overview of the different scans, so it remains on the scanner. And we can also export it. We will use PLY. You have like a lot of different formats, but PLY is, for me, for my like reverse engineering tasks, the most useful one. If you want to 3D print, I would guide you to using STL because they are most supported by Sliceders, or maybe OBJ, but OBJ has some disadvantages since it is mainly used for texturized models, including texture. So let's export. We will name it screw. And now we can export a scan. It basically gets downloaded as a zip folder. Now we can extract it and have a look at the file in MeshLab. Yeah, I have MeshLab installed. So yeah, I would say for such a small screw, the results are quite nice. So maybe with a bit more processing time and preparation times, the results would even be sharper. So I didn't use additional smoothing. The mesh alignment could have been done nicer by me. But yeah, it looks quite nice and usable for like a screw maybe 0.5 centimeter off in diameter, 4 millimeter in diameter. It's quite impressive. Therefore, hope you enjoyed watching the video. And if you have any additional questions about the Meta Inform 3, feel free to ask them.